Welcome to the IAA Transportation Podcast.
Welcome to a new episode of the IAA Transportation Podcast. My name is Tim from the IAA Communications team, and today we are discussing the role of artificial intelligence in fleet management, especially in the area of electric vehicles. Our topic today is AI optimization in fleet management, and we have a very special guest with us today. His name is Heikki Laine. He's the VP product at Widesense. Mr. Laine, Heikki, welcome to the podcast.
Thank you for having me.
So could you briefly introduce yourself? What exactly does Widesense do, and what is your role as a VP products?
Absolutely, Tim. So Widesense is a software company. We're based in the San Francisco Bay Area in Berkeley, California, and we are a spin-off from the world-renowned Model Predictive Controls Lab at the University of California, Berkeley. This is a lab famous for bringing out some of the greatest talent in automated driving and electric vehicles. So, a lot of the 15 years of research that's been going on in this topic at Berkeley comes into our company. And what really sets Widesense apart as a software company is that we take a bottom-up approach to using modeling and using AI to optimize the way that fleets are used, specifically electric vehicle fleets. Traditional fleet management often relies on general data, averages, assumptions that can lead to inefficiencies. We use AI, however, that's built on real-world data from millions of data points. We currently have 10 million miles of experience with electric vehicles. And this level of precision helps us to eliminate uncertainties, understand uncertainties, and optimize everything from the way the vehicle is utilized to the charging schedules, to the usage, and create real cost savings and enhanced efficiencies for fleets that are decarbonizing. And as the VP of product, my responsibilities are around understanding our customers' needs, defining our solutions for those needs, and planning our roadmap for the future of electrification.
So it's a lot about, thank you, it's a lot about actually prediction. So let's dive a bit deeper into the topic. How you just mentioned, how do your AI solutions differ from conventional AI models often used in other fields? And what specific benefits, you just mentioned a few, but maybe you can go a bit further, can your customers expect from using your technology?
Yeah, let me start with just a good clarification to begin with. We are not in the space of large language models, ChatGPT, this type of AI that we see in a lot of technology today. We start with an understanding of vehicles. I mentioned that we come from a control systems lab of scientists working on electric vehicles. So we start by building physical models of the vehicles and their components to really understand how they work. And then we wrap these physical models within neural networks. And that's where the AI comes in. And this combination really gives us a unique solution where we truly understand how the vehicle components work, but then we use AI to help us understand and manage all of the variability that comes when these models are introduced into the environment, into unpredictable conditions, and into a variety of environmental situations that impact the way those models react. And it's all about doing that at huge scale, large numbers of miles to learn and continuously improve this purpose-built applied AI.
So the AI actually helps you to manage this huge scale of data.
The AI is most important for being able to predict how a specific vehicle will react in a specific environment. So, as an example, we will build a model of an electric vehicle that one of our fleet customers is using, a Ford F-150 Lightning, a city transit bus, whatever. And then we learn how that vehicle reacts in a variety of different environments and how different vehicles, even if they are identical in terms of their labels. So we have 10 of the exact, quote unquote, the exact same van. Each of them behaves differently. So we learn how each of them reacts when the weather changes, when the traffic changes, when the slope and curvature of the road changes. And this scale and this huge number of variables is what we leverage AI to be able to understand and predict how vehicles will react in all of those conditions.
It's really fantastic. I mean, the topic you just mentioned, like ChatGPT and what everybody understands when you say, AI. I mean, your company is working quite long on this. When did you start using AI actually and getting AI into your system?
So the company's been around for about 5.5 years. We started the company with a focus towards automotive solutions, so building AI for electric vehicles to help with route planning and navigation solutions. But we quickly realized that the scale that we are able to address with this technology, this AI, underlying AI technology that's been built in the lab for 15 years, can really help with bigger challenges. And I think this comes to a kind of typical startup mentality is how can we take the technology that we have and go and address the biggest possible challenge that we see on the market today. And that's when the company made the transition to work towards fleets. And we've now been working in the fleet space for 3 or 4 years. And fleets are a unique environment because they have so many vehicles. The vehicles differ from one another, and they're all doing very different things, but they need to be understood and operated as a whole, as a unit. And this is how our scale really helps.
I read that Widesense employs a bottom-up modeling approach for developing AI models. Could you explain how this approach works and what advantages it offers compared to traditional models based on factory specifications?
Absolutely. So a traditional approach is to take the factory specifications, what we call the nominal specifications of, let's use a battery, for example, just one of the components of an EV. And to use that and to build averages around those factory specifications. That's great when the vehicle actually adheres to those specifications. But what we found is that many vehicles don't adhere to those specifications even on day one. They certainly don't over time as batteries degrade and components change over time, and they behave differently in different environments. So what we do is build our own models of those components. I mentioned this is the bottom-up physical model. And then we wrap these with neural networks, and we use real-world experience to build digital twins of those specific vehicles, of each and every one. So we use data from telematics, data from fleet management systems to learn how the vehicles behave, and then be able to take that model and use it to predict how that vehicle will behave before it's in a particular situation.
That actually would have been my next question, but I think you just answered it. How do you ensure that your models accurately reflect real-world operating conditions? You just mentioned the twins, the digital twins. How does that work, actually, in a very easy, low level of explaining?
The easiest way to explain it is that we continuously learn, and we rely on real-world operations to be able to train the digital twins. So to train a digital twin to understand a real environment, you need real data. I mentioned that we've got more than 10 million miles of data. We've got more than 3,500 vehicles onboarded in the system. So we use this experience to train those models. And then we use the continued operation to validate those models. So once we've built the model and we understand we have the digital twin, that digital twin is deployed in the real world. And we use the continued operations to kind of check that the vehicle is behaving as we predicted it would. And we can continue to improve the models with that data.
And so you tailor your models for the individual needs of your customers. And how is this customization actually tested in practice?
Great question. So I'll start with the first part. Yes, we build everything to the customer's requirements. And this comes to the point of really doing a system-wide optimization. In a typical electrification plan where a customer says, I have a fleet of 10 vehicles and I want to electrify for whichever reason, the kind of legacy approach is to say, this vehicle needs to drive so many kilometers per day and it needs to carry so many tons, and that's diesel. So let me find an electric vehicle that can do the same. That's absolutely impractical. Most of the time, the electric vehicles don't have the range, they don't have the weight capacity, and a customer might even need to purchase multiple electric vehicles in order to do the work that they were doing previously with one diesel vehicle. So our approach is to start with the work, not what vehicles does the customer currently have, but what is the customer looking to get done with those vehicles. So we start with the work, the routes, the schedules, holistic view of the operation, and this goes into our global optimizer, which helps the customer, that helps us to explain to the customer and deliver to the customer a plan with how many vehicles do you need, what should those vehicles be doing, and how should they be operated on a day-to-day basis.
That's really interesting. And can you tell us more about the advanced scenario simulation? How exactly does these simulations work, and how do they improve the decision making in fleet management?
So our simulation differs from traditional approaches, I think, in one big way, and that is a traditional fleet operator would take a simulation tool, they exist on the market today, and do trial and error. Try, input, this is the number of vehicles I would like to try, this is the number of chargers I would like to try, run a simulation one by one serially and see if it works, in short. What we do is understand that work, and then our optimizer builds a solution, which is then iteratively fed at large scale through a cloud simulator. So we can simulate millions of scenarios minute by minute in, let's say, on the worst weather day of the year, on the best weather day of the year, on the worst traffic day of the year. And all of this is able to be done at scale. And we're not asking the customer to guess what they think would work and then check it. But in fact, we are optimizing and then running it through this large scale simulator to show that it will work and to give them a feasibility analysis of that solution.
And how is the feedback actually of the customers? Are they trusting the system, or are they a bit skeptical? Because I can imagine that maybe for some of them it's a bit, I don't know, scary that you can use data in that scale way and just to have that prediction actually. So how's the feedback actually for the customers? That's very important, I guess.
Super important. And I think there's a lot of talk of AI, a lot of hype about such things. But at the end of the day, it's putting vehicles on the road. I mentioned that we train models, and then we deploy models, and then we continuously improve models. So for each and every one of our customers, once we've done a plan for them, once we've deployed with them, we track those key performance indicators on a daily basis so that they can see that the Widesense solution is doing what it was intended to do. How much is it improving the utilization of their electric vehicles? How much is it reducing their charging costs? How much is it reducing the number of incidents they have where a vehicle runs out of energy on the road? And this is how we build confidence with the customer and create this transparency, clear KPI dashboards for them to be able to see the improvements that we're making.
You mentioned that your technology helps significantly reduce operating costs or charging costs, we just learned. Can you provide maybe a concrete example or case study that demonstrate the cost savings your customers have achieved by using your solutions?
We recently did an engagement with an on-demand service fleet. So this is a fleet that does not drive fixed routes. This is a fleet that gets a call from a customer and sends a truck out to provide service to that customer. And this fleet was interested in shifting to electric for environmental reasons. They wanted to move to electric vehicles to get away from their internal combustion fleet, but they also wanted to do that without increasing their costs. And this was the challenge that they gave to us. With this fleet, we analyzed 2 years of historical call data to understand their work. we built them a plan, and we were able to reduce their total cost of ownership by 23%. At the end of the day, it was actually cheaper for them to move to electric than to stay with diesel with our optimizations. And this was largely focused on just smarter understanding of how to use chargers and when to use the chargers to charge the vehicles based on their tariff structures and the work that they're doing, because we understood when the vehicles are available to charge and where they are.
Well, that's really impressive, actually, because I think a lot of people and a lot of fleet operators, they're always a bit, I don't know, scared or afraid that changing or introducing electric vehicles to their fleet, that could actually, regarding the cost, that could be like super expensive. But that case study is the example, it's a real example. That's really impressive. In your opinion, what are the biggest challenges fleet managers face when they're introducing and managing electric vehicle fleets? And how does Widesense help to overcome these challenges?
I think the biggest challenges or the biggest questions that fleet operators need to ask themselves when they go to electrify is, why am I doing this? As you mentioned, electrification can be expensive. The vehicles are generally more expensive than diesel. You have to put in new infrastructure, but they're cheap to operate. If they're run smartly, they can be less expensive than internal combustion engine vehicles to operate. But I think so. Coming back, the biggest challenge is, why am I doing this? Because as I mentioned, we track KPIs with our customers. Are we delivering on the value that they wanted to deliver? And the most important thing is to start with an understanding of, why are you doing it? What will you track so that you can see that you're making progress towards those goals? Am I doing this to decarbonize? Am I doing this to reduce the number of vehicles in my fleet? Am I doing this to reduce my fueling costs? And this is the most important piece of any electrification plan.
Do you have example from, I just wanted different regions. For example, I guess you're operating a lot in the US, but outside the US, are there different challenges? You mentioned the weather, but also the infrastructure, the charging infrastructure is quite differently over the whole planet.
Sure. We operate in North America, in Europe, and in Australia currently. And I'll bring two regional specific things that we consider that are really important. We're working with a few fleet operators in the Nordics and in Northern Europe. And there we see really extreme weather conditions in the winters. So for example, an electric vehicle might have half the range in winter on a day than it has in summer. So really being able to understand how far that vehicle can drive on a specific day, not just in general, is critical for being able to plan its operations. So that's really one of the key things that we're able to do with our AI. And secondly, you mentioned charging. Charging is one of the biggest costs for an electric vehicle. So having an understanding and modeling the tariff structure, the way electricity is charged to the customer in a specific region, is also something that we spend a lot of time on to do that optimization. Here in the US, many operators don't even pay a demand charge. So they don't pay more when they use large amounts of power. And their power costs are pretty stable day to day. Whereas with our clients in Europe, they might be doing spot pricing where their energy prices change day to day. Their energy prices might even change at different times during the day. And we need to build all of that into our models.
Well, that's a huge number of data, I guess.
Yes, there we come back to this large scale simulation that I mentioned earlier. This is why it's critical, right? We have to be able to build all of this and do it minute by minute for all of the vehicles to be able to understand what those costs look like, because the impact of those costs can be tremendous if they're not done properly.
You just mentioned tires, for example, in the car or the vehicle itself. How do your AI models contribute to predicting maintenance needs and minimizing downtime in the electric vehicle fleet?
So we do provide some amount of predictive analytics for electric vehicles. One great example would be able to identify battery issues. So as we are monitoring how the vehicles behave, we can see anomalies in the behavior. We track the vehicles over time, of course. The batteries degrade over time slowly, but we can also see micro events in the behaviors of the vehicles that can help operators go back to their maintenance teams and understand. So for instance, if a battery has a string loss, and we can see that in the way that the vehicle is behaving, we can give that data back to the fleet operator, who can then go to the maintenance team and say, hey, have a look at this truck or have a look at this bus. There's something going on with the battery.
So to make it clear, you can actually, I'm a fleet manager and have a wonderful fleet, and then you can say, oh, Tim, listen up, your vehicle XYZ, it should go to the maintenance shop actually, because there will be a problem coming up. And I can say, okay. And if you don't say it, next day on the street, there could be like, yeah, a big problem for my fleet.
Bingo. Being able to identify those vehicles before something happens on the street is absolutely critical, because the most expensive place to have something happen to the truck is out on the road.
That's actually, that's the thing that I said in the very beginning. That is what I'm so keen about, the whole AI prediction. I think that's a big game changer, and also really impressive, really impressive. And I guess that's something your customers are really satisfied about as well.
There's so much variability in the way that electric vehicles behave and how they behave over time. So the more insights that we can give to them, the better they can plan their operations going forward.
We just had a theoretical success story, the one of Tim's fleet actually being saved from having huge costs by being not able to drive any further on the street in Australia, maybe. But what specific success have your customers achieved by using your AI solutions? Maybe you can share a real success story where Widesense AI solutions made a significant impact on an EV's fleet operations.
I would use an example of a delivery fleet that we worked with. So this was a delivery fleet of medium duty trucks, making deliveries of packaged goods, beverages, and foods, that was looking to electrify. And they went ahead and built their own electrification plan, and they took a small subset to start with, and they bought 5 trucks to replace 5 diesel trucks. We came in, we did our analysis with that fleet, and we were able to show them that work was capable of being performed with only 3 trucks, which meant that they had an additional 2 trucks. 40% of the vehicles that they have bought could now be used to electrify even more of their fleet. So you can imagine how powerful this is for the fleet operator to be able to go back to their board and say, we said we would have electrified this much, and we actually electrified considerably more by just bringing in a software solution.
What technological hurdles did you have to overcome actually to adapt your AI models to the specific needs of the fleet manager, like the company you just mentioned?
The biggest technological challenge is really having access to the data and making it available. And every engagement that we have with a customer starts with that. We understand the work that they want to do. That's great. That's for understanding the problem space. And then to build their solution space, the next step is really to get a deep dive into what data do they have about their work, about their vehicles, about their fleet, and what kind of telematics access do they have. It's not rocket science, but it's scale and it's critical. AI can power a lot of things, but it's fueled by data. And if you don't have fuel, you cannot power your AI models. And I think that is the biggest technological hurdle for most fleets, is making sure that they have data available to feed the AI.
What partnerships has Widesense established to further develop its technology and its services and expand into new markets? You just mentioned North America, Northern Europe, and Australia, but what is your company's goal? What I guess it's a lot of more areas actually can benefit from your solutions.
We started our business in the transit space, actually, so city buses, because these are large fleets that are electrifying, that are interested in not only cost reduction, but also in decarbonization for public good, for making fleets green. We've since expanded into commercial fleets. This is largely in the delivery space, so middle and last mile delivery. And we're also working with rental car fleets. So essentially, any segment that's got a large amount of electric vehicles that wants to reduce their carbon footprint and reduce their costs are the customers that we are aiming to help with this software solution.
And what can we expect from your company at IAA Transportation?
Widesense will be exhibiting at IAA Transportation. We will be showing our solutions for planning and real-time operations for electric fleet operators. So we would be happy to show fleet operators case studies and demonstrations of our technology of how we have helped electric fleet operators select what kinds of EVs they need, how many EVs they need, how should they adapt their operations to be able to efficiently and cost effectively bring EVs into their operations, and the software that we provide to make that easy on a day-to-day basis.
So let's have a look a bit more further in the future. Beside IAA Transportation next month, what technological developments do you anticipate in the next 5 years that could further revolutionize the fleet management?
The entire mobility industry, with fleets as no exception, is moving towards greater integration of AI and real-time data analytics. So for us at Widesense, we're super excited about the potential of things like real-time charge management, predictive maintenance, operational efficiency improvements, all powered by AI. These innovations are designed to not only respond to the current challenges, but to anticipate the future needs and allow these fleets to operate more efficiently and more sustainably. And we really believe that the future of fleet management lies in harnessing the power of AI to make these proactive, data-driven decisions that benefit both the environment and the fleet operator's bottom line.
So what role will Widesense play in supporting the global fleet electrification goals?
Our solutions really span end to end. We provide services to help these fleet operators plan, implement, and finally deploy and maintain these electric vehicles throughout the entire life cycle of their transition to electric, which we see really accelerating across a number of fleet segments today.
And what new features and technologies can we expect from Widesense in the near future that could further revolutionize or optimize the fleet management? We're just talking about AI, and we know that AI is currently learning. It's getting better and better every day, every second, more data, more, it's always getting somehow better, or it's getting more intelligent, or it gets clearer with the way of prediction. But what is the next step for your company?
We are hyper-focused on providing the best possible predictions for electric vehicle fleets. This is the core of our technology. This is the core of our team. And this is our biggest differentiator from legacy approaches. And this is where we spend and invest our R&D, is making sure that we understand as much data as possible, apply that data as efficiently and as richly as possible so that we can just continue to improve the accuracy of our forecasts, which are then used for a countless number of features and customer value points, as I mentioned, everything from understanding issues with your battery to planning your routes to identifying potential warranty issues with your vehicles. All of this comes down to having a super accurate vehicle-specific model. That's where we're focused.
We just spoke about huge scale data. We spoke about the future, and there's one big topic in the field of mobility, in the field of automotive, that is actually kind of really close to that, to, let's say, buzzwords. That is autonomous driving. So to what extent is Widesense planning to develop and offer its technology for autonomous vehicles? What challenges do you foresee in this area?
Our team has a lot of experience in autonomous vehicles. I mentioned in the beginning of the cast that a lot of our team comes from a lab that built technology for these vehicles. As we look at it, the autonomous vehicle is really quite similar to an electric vehicle driven by a human, with just one difference. The driver is software instead of a person. Today, we learn driver behavior and we use it to do our predictions and to build our models. With autonomous vehicles, it's really no different. We use the same methods to learn how a robot driver or a software driver behaves, just as we would for a human driver. So we find our solution really portable for the shift to automated driving as it starts to come into the picture.
So it sounds like you're really future-proofed in that field, aren't you?
We've got the electrification has a long way to go, and our roadmap is looking to all of the impacts that are coming into that so that we can manage them as they do.
How actually do you see Widesense role in the future collaboration with cities to ensure seamless integration of fleet management solution into urban mobility concepts?
At Widesense, the actual type of vehicle really isn't so important. I mentioned that we're working with large trucks, light trucks, buses, passenger cars, all at scale. And so as we look to essentially any type of electric on-road mobility, we can build models and onboard them into our system to be able to help these cities and fleet operators improve the efficiency of those deployments.
Thank you very much for the deep insights into the work of Widesense and the future fleet management. Thank you so much for your time. And I guess it's time for coffee now because it's morning in the East Coast area. And I just recommend everybody who's interested in those topics to check out our other podcast episodes, our social media, our weekly, and most of all, I really recommend to visit the booth of Widesense at IAA Transportation. Thank you so much. It was nice having you.
Thanks for having me, Tim. Looking forward to meeting you and all of the other attendees in Hanover in a few weeks' time.
Great. Thank you so much.
For more information about IAA Transportation, visit our website or check out our social media channels.